Hey everybody, Nicolette here with Insomnicat Media. Today we're going to talk to Jim Witham from GaN Systems about the future of wireless power. Stay tuned.
Hi guys, I'm Nicolette with Insomnicat, and today Bryan and I are chatting with Jim Witham, CEO of GaN Systems. Hi Jim, how are you?
Hi Nicolette, very good.
Thank you so much for joining us. Today we are going to talk about wireless robots, a little bit of creativity, so I'm really excited. Jim, do you want to tell us a little bit about yourself and GaN before we get started?
Sure. GaN Systems makes power transistors. We make them out of gallium nitride. They're the world's best performing transistors. And with those devices, my customers can make things much more efficient, so you don't waste energy, can make power electronics much smaller, typically 4 times smaller, 4 times lighter, and save some money on the total system cost in the meantime. So it's a pretty important product in the terms of power electronics and the energy that we use in our daily lives.
Awesome. So earlier in the summer, we were thinking about this. Earlier in the summer, your VP of Marketing, Paul, he gave a talk about moving to a world without wires at Wireless Power Week. So in your opinion, what does a world without wires look like for the everyday consumer or even the business professional?
Yeah. Well, when I look at my life, both business and at home, 20 years ago, everything was wired. My phone was wired. My computer was wired with an Ethernet cable, and everything was powered up with a power cable. And 20 years ago, cell phones came out. We cut the phone cord. 10 years ago, stopped carrying around an Ethernet cable with me. Everything's done wirelessly now. And so I think it's only natural that the kind of final cord, the power cord, we're going to cut also. And so I think it's just a matter of time when that all happens. And some of it is also technology related. You've got to have the right technology to make it practical. And we're starting to see that these days.
Now, on the topic of business and wireless, what about applications like smart offices? Do you have any thoughts on, some ways that wireless technology might seep into the future smart office?
Yeah, absolutely. I think that an obvious space is charging your computers and phones. And so I think what we'll see, and we already have at GaN Systems, is conference rooms that have tables that have wireless charging on them. So when we have a meeting at headquarters in Ottawa, people just throw their phones on the table and they charge. No wires need to be connected. I think the same thing will happen on the office desk. We'll have a space, maybe it's 3 feet by 2 feet on your desk where you can place any of your electronic instruments and they'll charge. No wires need to be hooked up. I think it goes beyond that, though, just simple computers and phones. I think the day is not too far away. We'll be driving our electric vehicle up and we'll go park in a parking spot that has wireless charging for the car. I don't know if you've ever been up to Ottawa in the wintertime, but it's cold. There's a lot of snow around and it's not a lot of fun to have to plug in a cable into an electric vehicle. It'd be nice if it just charges. The charging happens just automatically when you park your car. And then another,
you got to make this. You got to make the spot big enough to see it under the snow, though, right? So they know where to park the car.
Yeah, you can go through the snow. You still got to know the lines on the parking spot, though. Yeah, so
right.
The removal guys got to get up at 4 in the morning to go make it happen. And then another interesting application where we're seeing GaN go into wireless charging is in the 5G world. It's 5G's incredible because you can get this vast amount of data through the air and stream video to your phones and computers. But one of the problems that it has is it can't go through walls, and so You've got to have a receiver on the outside of the wall or the outside of the building, and you got to have a transmitter on the inside of the building. And so we're doing wireless charging through the walls to be able to power those receivers on the outside of the building and be able to get this tremendous amount of data wirelessly through 5G into the office. So
That's pretty
conference
awesome,
rooms,
Jim.
charging the car, and 5G communications are all things that are happening in the smart office.
Do you also see like a lot of home devices, right? You know, because like you say, even in the office environment, you know, you can make everything wireless. It's interesting too, because you bring up that, you know, whether you're installing like cameras on your house, right? Those, you still need to plug them into an outlet somewhere, you know, even though they're connected wirelessly.
Yeah.
Do you see the market being biggest for the wireless charging sort of in the home space? Or do you see it being in the commercial space, like the office space, where you're able to provide those things in the office? Or which do you really see emerging first out of the two, like the business aspect or the consumer aspect?
Right.
Or automotive?
No, so I think it's a business and home over automotive. It's harder to get those big power levels for the car, so there's more technology to be done. But you know, absolutely, security cameras. It's hard to find power for them outside the house, and batteries just aren't a great option because you got to switch them all the time. So security cameras and wireless charging through the wall absolutely makes sense. I use wireless charging from my phones on my office desk. I've got one on the bedside table. It's really nice to just put the phone down and you have it charging. You don't have to worry about fiddling with. So I think those are obvious applications. We have them in our conference rooms. You know, I spend half of my time at work and half of my time in the office and a few hours sleeping. I need wireless charging in both places.
Yeah, absolutely.
So I have a question. Because I know some people who are skeptical about technology in general, but wireless, for instance. So, they might say wireless isn't better. It's not more productive. There's longer charging times and, instability while charging, that kind of thing. So what would you say to skeptics who believe that wireless really isn't going to be better?
Yeah, absolutely. Those are good points, Nicolette. There's three things you got to have in order to have good wireless charging and make it ubiquitous. One thing you've got to have is lots of power. Lots of power because you need rapid charging. You want to be able to do multiple devices. You got to have spatial freedom. It means the power's got to go over a big enough distance so you don't have to align things up just right. You can kind of throw them on the table and it happens. And the last thing is you need efficiency. You need it to be as efficient as plugging in a wire because we don't want to waste energy. And what's held back wireless charging in the past with the Qi implementation is it was very low power. You had to align it perfectly, and it wasn't very efficient. And so that's been conquered, and GaN is a big element in conquering that. So we're doing up to a kilowatt. So we're doing hundreds and hundreds of watts of wireless power. We're doing it over distances of 12 inches, 300 millimeters. And we're doing it with efficiencies over 90%. And so when you get to those levels, then you can go implement all these applications.
Oh, that actually answered some of my questions about the challenges.
That's also important when you talk about earlier, you're talking about charging automobiles. You need that distance, right, for the contact from, the distance for the car to charge and the amount of power. So. Exactly.
If you go from the ground level up to, the bottom of the car, you probably need 12 inches or 300 millimeters. A few millimeters isn't going to get it done.
Yep.
So can we switch gears for 1 second and talk about robots? Because we love robots and everybody loves robots. Earlier this year, GaN Systems discussed the value of high-power wireless charging for autonomous robots, as well as the importance in Industry 4.0. So, one of our sites, ParperCure.com, focuses a lot on smart manufacturing, right? And it seems like wireless charging solutions using GaN tech really do have the power to change the world, specifically to recreate the industrial setting as we know it. So do you anticipate more manufacturers hopping on the mobile robot bandwagon as more wireless solutions become available? Or, is it other roadblocks that are preventing them from reaping some of these benefits?
Yeah, it's already happening, especially with robots that move around factories and with drones. Kind of the whole delivery aspect, that last, 100 meters of moving things around, those are really important elements. And so, it can be as simple as, connectors are a common failure in electronics. And so with wireless charging, get rid of the connectors. You don't have, you're not susceptible to moisture, you're not susceptible to dust, you're not susceptible to debris. If you use wireless charging. And drones are an obvious one, right? If you take a drone and it flies down into its landing pad and that pad is the charger, there's no connections that have to be done, and you're off to the races.
Do you see this kind of growing from here then?
So do you envision like, is it really envision like there's pads all around the factory, right? So there's, so whatever type of robot you have, there would be, for instance, pads all around the factory that they could charge, or would it be even like sort of, if I'm going to use the drone, for example, say, for instance, it's pulling stuff from shelves, right, and moving it on. Would there be, even when it's in contact with the shelf, picking up the package where it could grab some power? Do you know what I mean? In motion, or while it's performing its current action?
Yeah, absolutely. I mean, and I have the same vision that you have, Brian, and that's the warehouse. Think of an Amazon warehouse, and you got gobs and gobs of products all over the place, racks of product, and then so the drone comes in, gets a product, picks it up, takes it over to the box. So whenever it's kind of not in motion between the packing station and where the inventory is, it's an opportunity for charging.
Exactly, because you could even imagine, like, things flying midair, right? Say it's even delivering, doing home delivery, things flying midair, having charging stations on, a telephone pole. It's stopping, fueling up a little bit, and then moving on to where it needs to go. As it sort of, as it jumps gaps, as it pings from one place to the next, you can envision it, picking up power as it needs it.
So you bring up a really interesting topic. It's kind of 2D charging versus 3D charging. There's been some 2D charging examples for automobiles or buses where people have put charging stations in the bus stations and along the road. Qualcomm did some interesting work here. So that's kind of 2D because you know where the road is and you know where the car is. When you're flying a drone, you really need 3D charging. I can see that being a good application for drones. It's hard to get power over long distances, so there's some technical challenges to overcome. But think about 3 people sitting around a coffee table at Starbucks. Everybody's sitting there with their 2 thumbs up and their phone in their hands, texting away. If there was a charging cloud there where you actually weren't drawing down your battery, but you were charging your battery, that would be a pretty cool way to keep your phone fully charged.
Right, and especially, with distances of, like even 12 inches, when you're sitting there, if you're talking about Starbucks, you're sitting there, your elbows are on the table probably when you're texting, right? So your hands are roughly 12 inches above or less, probably above the table itself. But the same thing with drones. Like, say, for instance, it was flying out into, some neighborhood. If you had those stations or those pads, sitting, whatever, I'm just making this up, but, above the phone pole, it could hover above the phone pole and pull the power right out of the pole itself. Absolutely.
You have the vision.
Yeah.
Look at that, Brian. You're a visionary.
That's why Nicolette keeps me around.
True. It's true. So I do want to talk a little bit about GaN Systems and any new and cool things that we can expect from the company itself and things that are being worked on or things that you're releasing or any challenges you're overcoming in the industry. We'd really like to focus on that for a minute.
Yeah, so we have a full product line of 650 volt and 100 volt transistors that are used in applications as diverse as chargers for phones and computers, to data center servers, to factory motors, solar installations, and electric vehicles. We do have 3 new product lines that we've come out with, and I'd encourage your listeners to go to our website and look at those. One is a low current, low cost part that's particularly good for consumer applications. A second product family are very high current parts that are used in electric vehicles and factory industrial applications. That's 150 amps, 650 volt GaN transistor. People are doing as much as 75 kilowatts with that part. So a pretty breakthrough product. And then the third area is we have a second generation automotive line that's very appropriate for onboard chargers and DC to DC converters. So any of your readers with applications in those areas should go look at the new products that we've come out with.
Awesome. And last thing, Jim, we love creativity. And, you know, I think there's a lot of creativity linked to technology and engineering. So what are your thoughts on even GaN technology and how the space is evolving, unleashing new levels of creativity for individuals across all industries?
Yeah, I mean, I think if you look at any industry, whenever there's a change in kind of one of the fundamental building blocks, one of the fundamental tools, then brand new things happen. You know, an example in a totally different area is, you know, when people figured out how to do a mitochondrial DNA test, look at the female side of DNA, it opened up all these things we learned about populations of people. In power electronics, we have a new basic building block. It's this GaN power transistor, and it unleashes a lot of things that designers can do to create revolutionary products. So we're in the midst of a power revolution. It's being driven by power transistors and the advances, and engineers should take a look at these things because they'll be able to do remarkable things with their products.
Awesome. Bryan, am I forgetting anything?
No, I think it, you know, to your point, you know, Jim, it opens up like a completely new world of what you do with electronics, you know, being able to do wireless charging, you know, it really seems like it's the next, you know, it's the next thing they should really get creative with in incorporating them into the product lines they're developing.
Yeah, I hope to be sitting at a Starbucks with you and Nicolette a couple years from now, and we can be texting away and charging our phones at the same time.
Driving up in our electric vehicle and charging in the parking lot while we're waiting.
There you go. I love it. That visionary stuff's coming out again, Bryan.
There you go. There you go.
All right, Jim, thank you so much for joining us today. This has been a really fun talk about technology. Thank you very, very much. We really appreciate it.
Well, thanks for having me. It's always a pleasure to talk with you and to talk about what the future looks like. If your viewers and your readers would like to get more information about GaN power transistors, about GaN systems, I welcome to come to our site, www.gansystems.com, and there's a ton of information on products, applications, and how to use the devices and where they're used.
Great, thank you.
Awesome. Thank you so much, Jim.
All right, bye-bye.